All right, so today we're going to be going through 2016 and 2017 paper, right? And they have a few new questions on this paper. All right, so we're going to go through 2016 and 2017. All right, definitely. So Jordan and Sharik, I'll send you the IA grade at the end of class. Just remind me closer to when we're finishing. Yeah. All right, so today we're going through 2016 and 2017. So let's kick it off now. So question one, clear and easy. It's asking to simplify that. So what's the answer for question one? Because this one repeats so many times. What's question one? So for question one, you don't even need to actually rationalize. Like, let me tell you an easy way to do this. You can just put all of this in a calculator and check which one of these answers is the same as a calculator. Where a calculator get. So you put in a calculator root 8 plus root 32 minus root 162. And what your calculator is going to give you is minus the square root of 4.24. That's what your calculator is going to give you. And check which of these give you minus 4.24. So minus 3 square root 2 is minus 4.24. And so that's A. So that's question one. Question one is alpha. Question two, it says, which of the following, if g of x is the inverse function of f of x, then which one is the correct diagram to show the relationship between the two? Well, the relationship between an inverse and its function is a reflection in the line y equal x. So you just need to draw the line y equal x, and which one ever give you the reflection, that is the inverse. So this is a line y equal x, and over here, this side is a reflection of this side. And so this is the inverse. So that's C. Question 2C. Question 3, we're rationalizing. So in order to rationalize, we just need to multiply the numerator and the denominator by the conjugate of the denominator. So we have the root of x minus the root of y, and we'll multiply it by the conjugate of the denominator. The conjugate of the denominator is root of x minus the root of y. So we have root of x minus the root of y. That's divided by the root of x plus y times the root of x minus y. So multiply by the conjugate of the denominator, and what we're going to be getting now is that we just simplify the numerator. So we have root x times root x is x. Root x times root y is minus root xy. And then root x times root y is minus root xy. So we're getting minus 2 root xy. And then root y times root y, that's going to give us just y. So before we even finish the question, we can clearly see that the answer is the one that's going to have x minus 2 root xy plus y. That simplifies out to be C. So number 3 is C. Easy question. Question 4 is asking for the remainder. It says if a remainder of 7 is obtained when x cubed minus 3x plus k is divided by x minus 3, then what is the value of k? To find the value of k, then from this, if x minus 3 is divided into this to give a remainder of 7, then what we know is that f of 3 is equal to 7. F of 3 is equal to 7. If f of 3 is equal to 7, we plug 3 into this function to get 3 cubed, which is 27, minus 3 times 3, which is 9, plus k, and that must be equal to the remainder, which is 7. So all you have to do now is solve for k, and when we solve for k by making k the subject, we're going to get minus 11. So that's A. That's number 4A. Easy, soft. All right, question 5. Question 5 is asking for not P and not Q. When you simplify that, what are you getting? You're going to get the exact same thing, so you can just remove the bracket. Not P and not Q. Really easy. Question 6. Question 6 says that if x and y are negative, which of the following is true? If x and y are negative, then use an example. Negative 3 is greater than negative 4, right? But if you square them, you're going to see that negative 4 squared is greater than negative 3 squared. And so if x is greater than y, then what we're clearly seeing is that x squared is then going to be less than y squared. That's what we're seeing when we square negatives. So x squared is less than y squared. That option is delta. That's question 6. Easy stuff. Question 7. Question 7 is asking us for the range of values of x that will satisfy this inequality. So whenever, this is a general rule with inequality, whenever the modulus of x is less than r, then x is between r and minus r. That's a rule. This is a rule that we must know. If the modulus of x is less than r, then x is between r and minus r. So from that, if we're solving for the modulus of x minus b to be less than a, what we're getting is x minus b is between a and it's between minus a. If x minus b is between minus a and positive a, then what we're getting is that x is between a plus b, and we bring b over here as well, and we get a minus a plus b. So x is between a plus b, and also x is between minus a plus b. So that looks like option A. That's for alpha. Easy question, soft. All right, question 8. Question 8 is asking which of the following mapping diagrams does not represent a function? In order to know which does not represent a function, there's what is known as a vertical line test. If you do a vertical line test and it cuts the line at only one point, then it's a function. If it cuts it at more than one point, then it's not a function. So looking at the options right here, what we can see is that for option C, right here, when we do a vertical line test, we notice that when x is a particular value A, it is being mapped to 2 points. And so by the definition of function, each element in the domain must map and map to only one element in the range. And so C is not a function. So that's Kramer, C. Question 8. Question 8 gives us a log function and it wants us to find the value of x. To find the value of x, well, we're just going to get log base A of, whenever you're adding two logs, you just multiply them. So 4 times x, it was log to base A of 4x. Then it says subtract 7. So since we're subtracting log 7, we're dividing by 7. So the log of base A of 4x over 7 is equal to 2. So what this is telling us is that 4x over 7 is equal to 4x over 7 is equal to a squared. 4x over 7 is equal to a squared. And so x is equal to 7 over 4 a squared. So that's question 9. Question 10, it is asking us to find log root 6 of 36. There are 2 ways we can attempt to do this question. Well, let's do it the easy way. You can convert it into log to base 10, and it is log to base 10 of 36 divided by log to base 10 of root 6. This way is very easy because then you can just put it in a calculator, and what we're getting is log of 36 divided by the log of root 6 is going to give us 4. So easy. And that is option C. Easy, soft. Question 11. Question 11 says, which of the following sets of ordered pairs represent functions? It says represents functions. All right. So each element in the domain must map and map only to one element in the range. So we have -1, 0, 1, and 4, all of them mapping and mapping onto one element in the range or codomain. So I is a function. Now look at 2. We have -2 being mapped to 4. We have 1 being mapped to 1 and 1 being mapped to 4. Since 1 is being mapped to 1 and 1 is being mapped to 4, this element 1 in the domain maps to more than one element in the codomain, and so II is not a function. This one is not a function. So all the options with 2 are out. II not a function, II not a function, II not a function. So the only possible answer is delta. Easy, soft. All right, let's go further. So we have log 15 minus log 6 plus a half, log 4 over 25. You can actually just put all of this in your calculator. So put all of this in your calculator, you're going to get 0. This is a calculator question. So put in your calculator. If you don't want to work it out, that is, just put in your calculator. Easy question. All right. Now question 13. What is question 13 asking? It says, which of the following are factors of this function? In order for it to be a factor, then what we need to check is if f of the value into this function is equal to 0. So we need to check if f of -1 is equal to 0. We need to check if f of 1 is equal to 0, and so forth. So plugging in -1, we're going to get 4 minus 8, that's -4. Then we're going to add 4, that's 0. Then we have -6, that's +6 minus 4, which is 2. So since we're getting 2, which is not equal to 0, so therefore x plus 1 is not a factor. We'll put in 1 now, we're getting 4 plus 8 is 12 minus 2 is 10, 10 minus 6 is 4, 4 minus 4 is 0. And so f of 1 is indeed equal to 0. It should be f of 1. F of 1 is indeed equal to 0, and so this is a factor. So we do the same for -2, so we'll put in f of -2. Plugging in f of -2 in this equation, we're going to likewise also get 0. And so option 3 is also a factor. So since 2 and 3 are factors, that is beta. So beta is the only option there. Easy, soft. That's question 13. Question 14. Question 14 is asking, what is the general cubic equations with root alpha, beta, and gamma? So the general equation of a cubic, if we recall, it's x cubed minus the sum of all the roots times x squared plus the product of two roots times x minus the product of the three roots, and we set that being equal to 0. So the sum of the roots will be alpha plus beta plus gamma. Product by 2 is alpha times beta plus alpha times gamma plus beta times gamma minus alpha, beta, gamma. And so what we're getting is, looking at it, it looks like beta is the answer, B. This one follows this form, B. So that's the answer. Nice. Question 15. It says, the tables below shows the values of two functions, f and g. Find the value of g inverse f of 3. To find g inverse f of 3, what we need to do is right here now. So we need to find g inverse f of 3. So first we find f of 3. F of 3 is when x equals 3, we're getting a corresponding value of 2. And so we can write that down, that f of 3 is equal to 2. Now, since f of 3 is equal to 2, what we actually want to find is g inverse. What we want to find is g inverse of 2. Now, if we're finding g inverse of 2, subsequently, what we're finding is what value of x is giving us that g of x is equal to 2. That's what that means. So we're solving when g of x is equal to 2. Now when g of x is 2 right here, the corresponding x value is 5. And so therefore g inverse of 5 is equal to, therefore g inverse of 2 is equal to 5. So that is C. C meaning 2 easy. So that's an easy question. Question 16. It says that we have a vector equation given by s times minus 2, 1 plus t times 1, 1 is equal to -5, 1. Find the values of s and t. So from this right here, we have minus 2s plus t is equal to negative 5 equal to negative 5. That's one equation. We'll group the x coordinates. Grouping the y coordinates, we have s plus t is equal to 1. So what we can then do then is subtract. And when we subtract them, we're getting minus 3s is equal to, that looks like minus 5 minus 1, that's negative 6. And so what we're getting is that s is equal to 2. If s is equal to 2, then t must be equal to negative 1, because 2 plus negative 1 give us 1. And so t equal negative 1. So that is 2 and negative 1, which is delta. Question 17 says that find the value of cosine pi by 2 minus p. To find cosine pi by 2 minus p, what we actually get is the cosine. When we expand, this is cos minus sine. So it is the cosine of pi by 2 times the cosine of p plus cosine of p plus the sine of pi by 2 times the sine of p. The sine of pi by 2 times the sine of p. So that's what we have. That's equal to cos of pi by 2 is 0 plus the sine of pi by 2 is 90, which is 1, plus sine p. So it's 0 plus sine p. And the sine of p is just sine p. So that's B. Easy. So now remember this, this is an identity. So that's an identity that we can also know that the cosine of pi by 2 minus p is equal to the sine of p. So that's an identity that they were actually showing us. All right. Question 18. Question 18 is asking us, they said a line through the points P and Q is parallel to the equation 3x plus y minus 21. Find the value of K. So we have the line PQ. So we need to find the gradient of PQ. So the gradient of the line PQ is equal to 8 minus 2, which is 6, over 6 minus K. That's the gradient of the line PQ. But now they said that this line is parallel to the line PQ. And so the gradient of PQ is equal to the gradient of this line, which is -3. So in order for this to be equal to -3, what we're then solving is 6 minus K. So we're solving 6 minus K is equal to, we cross multiply, so we're solving 6 minus K is equal to -2. So what we get is that K is equal to 8. Easy question, soft. All right, now this question is asking for the expression of the sine of 6 theta plus the sine of 4 theta. If we're going to work out what is the expression for 6 theta plus 4 theta, we just have to remember the sum of two sines. So the sum of two sines, that's the formula we're using. So that's equal to, it's equal to twice the sine of half the sum, sine A plus B over 2, which is 6 theta plus 4 theta is 10 theta divided by 2 times the cosine of 6 theta minus 4 theta, which is 2 theta divided by 2. So that's how we add two sine functions. And so adding two sine functions, this is going to lead to 10 theta over 2 theta is 5 theta. And 2 cos theta over 2 is theta. And so clearly the answer is C. That's question 19. Easy and soft. Question 20. Question 20 says, a curve is defined by the parametric equations x is equal to 3 plus 2t and y is equal to 2 plus t. So it says now what is the Cartesian equation of the curve? And so x is equal to 3 plus 2t and y is equal to 2 plus t. All right, so again, as I said, if you want the IA grade, ask me at the end of class because I'm going to have to go back into my Google Drive and go on the internet because somehow all my files got deleted off my laptop. So ask at the end of class. I'll give the IA grade. So just remind me at the end of class and you get your IA grade. So x, again, back to question 20. X is equal to 3 plus 2t and y is equal to 2 plus t. And we want the Cartesian equation of the curve. So we need to make t the subject. So we need to make t the subject. So what we're going to do is make t the subject from any one of these that you feel like. So I feel like making t be the subject from this one. And so what I'm getting is that y minus 2 is equal to t. I use the second one. You can use any one. Now I'm going to substitute this equation for t right here. So what I'm getting is that x is equal to 3 plus 2 times y minus 2. That's what x is equal to. X is equal to 3 plus y minus 2. And so what I'm getting that is okay, Malik, this year is 2016 paper. So 2016 paper is a paper that we're currently doing. And Giovanni, what class usually we finish at about in 2 hours time. So 2 more hours time. So usually about 6:15, 6:30. So yes, this is 2016 paper. And so all we need to do now is expand this right-hand side to get, this is going to simplify to be 3 plus 2y minus 4. And so 3 minus 4 is negative 1 plus 2y. That's what x is equal to. 3x is equal to minus 1 plus 2y. So we can bring 2y on one side to get x minus 2y is equal to negative 1. X minus 2y is equal to negative 1. So that answer is delta D. Easy, easy, easy question. Very easy. All right, easy question. All right, question 21. For question 21, we are being asked to find the value. Oh, also I will be sending, I'm going to send the multiple choice in the chat as well. For those that don't have access to this paper, this 2016 paper, I'll send it in the chat very soon. All right. So question 21, it says what value of theta satisfies this equation? So we need to solve this trig equation. To solve this trig equation, we just solve it normally like it's a quadratic. So we're going to factorize it. And so what we have is 2 cos squared theta. In order to get 2 cos squared theta, then right here has to be 2 cos theta. So right here has to be 2 cos theta. And right here has to be cos theta. That's only natural. That's the only way we can get 2 cos squared theta. Now, in order now to get 2, it needs to be 2 and 1. But then what it is saying right here is that we need for the middle term, when we add the 2 middle terms, so we're going to put a plus right here and a minus right here. And so what we're solving is 2 cos theta minus 1 times cos theta plus 2 equals 0. Now for this part is not valid. This part is not valid, and the reason for that is that the cosine of theta is always going to be between 1 and -1. And so when we're solving cos theta being -2, that's not going to give us a solution. So this is not valid. NV not valid. So we're only solving 2 cos theta minus 1 equal to 0. So what we're actually solving is 2 cos theta is equal to 1. And so we're solving the cosine of theta is equal to a half. Cosine of theta is equal to a half. And so what we're actually solving is cosine of theta is equal to a half. And so theta should be equal to pi by 3. Theta is pi by 3. All right, soft. Just a quick question. All of us have access to 2016 paper?
No, sir.
All right, so I'm going to send it. I'm going to send it in the chat. All right, let me know if you've received it. I've sent it in the chat. Have you seen it?
No, sir.
All right, let's check again. You see it now?
Sir, when I see it.
Not there? I don't understand. Should be there. All right, tell you what. Send me your email in the chat right here. So Tony and Cheyenne, you can send me your emails too as well. I'm going to send the papers by email with the solutions as well. So let's continue. All right, thank you, Malik. I'll send you in a few. Send it to your email. So that's question 21. Question 22. Question 22 is asking us to simplify. All right, thank you, Tony. So question 22 is asking us to simplify this expression. Simplify the expression of the cotangent of x plus the tan of x, right? How can we simplify that? To simplify this expression, well, cotangent of x, we just have to recall that the cotangent of x is cosine x divided by sine x. That's the cotangent of x. So let's write that down. We have the cosine of x, the cosine of x, and we're dividing it by the sine of x. And then the tan x, the tangent x, is sine x over cosine x. Sine x over cosine x. That's what we have. So that we need to let them have similar denominator, hence LCM. So the similar denominator that they're going to have is sine x, cosine x, sine x times cosine x. All right, so far that looks pretty simple. Then sine x into sine x cos x, leave cos x, and then cos x times cos x is going to square x, plus cosine x into cosine x, sine x, leave sine x. So what we're left back with is sine x times sine x is sine square x. Now we know that cos square x plus sine square x is 1, but we're not finished yet. Like this denominator, sine x over cosine x, what I'm going to do is put a 2 right here. All right, so the yellow is difficult for me to see, so let's put a 2 right here in black. Let's put a 2 right in front right here. So 2 over 2, right? That's just 1. So we haven't changed the value of anything. But then cosine square plus sine square is 1. So what we're getting is 2 divided by, now 2 sine x cos x is going to be sine 2x. Sine 2x. And then 1 over sine 2x is cosec x. And so this answer is 2 times cosec 2x. Easy question. Soft. And so that option is alpha. Alpha is that option. All right. Easy question. Now it is asking us to find for question 3 the maximum and minimum value of this function right here. And so to do that, first we need to start with is the sine of theta, as we know it, that the sine of theta is always going to be between 1 and negative 1. So it's greater than or equal to negative 1, less than or equal to 1. And so therefore 2 plus sine theta is going to be between, so we add 2 to both sides now. So 2 plus sine theta is going to be between 3 and we add 2 to this side is 2 minus 1 plus 2 is just 1. And so when we're going to take the inverse now, 1 over 2 plus sine theta, when you take inverse, you flip the signs. So flip the signs, it's going to be now less than or equal to 1 over 1 and greater than or equal to 1 over 3. And so what we're getting is that the least value, the minimum value is 1 over 3, and the maximum value is 1. So that option is cat. Well, if I'm going to, well, yeah, let's say cat. C. That's option C. What is the position vector of 3 times OA, where A has coordinates 3, negative 2? So we just multiply A our coordinates OA by 3, and so we'll get 9, -6. So that's nothing challenging at all with that one. That's option D. Question 25. Question 25 asks, which one represents the cosine of x over 2? Now, in order to do this question, the easiest way I would say is to draw a little table, and find out what is the value of cosine x over 2 look at the points they give you, 0, pi, and 2 pi. So find out what is the corresponding y value when x is 0, when x is pi, and when x is 2 pi. Find out the corresponding values when x is 0, pi, and 2 pi. When it's with 1. Now it's pi. We'll put pi right here. We really want to find over 2. The cosine of pi over 2 is, we need to know what is the cos of pi over 2. Cos of 0. Don't put in 2 pi right here. The cos of 2 pi divided by 2. 2 pi over 2 is just, so complete this table. And so we need to get when x is 0, x is pi, and x is 2 pi. These are the corresponding y values. That look like option B. Look at it. When x is 0, y is 1. When x is pi, y is 0. When x is 2 pi, y is -1. And so that is option B. Easy. So that's the easy way to do it. Option B. Nice. Question 26. Question 26 is a question. And question 26 tells us that we have a variable point P, and it moves in the same distance from the points. I'm going to call this point A. A is the point 1, 6. I'm going to call this point B. B is the point 3, 2. Then they want the equation of the locus of P. Said it moves in a way so that they have the same distance. So they're telling us that the distance AP is equal to the distance BP. Now the distance between the points AP, well, this we'll just use length of a line formula to find the distance AP, the square root of x minus 1, x minus 1 square plus y minus 6 square, and that's the distance AP, and it's going to be equal to B. BP is just going to be the square root of x minus 3 all square of square. That's the distance of BP. And BP is equal to AP, and so that's the answer. That looks like option C. That's option C. Easy, soft, with a capital T. Question 27. Question 27 is asking us to solve sine 2 theta equal to sine of pi by 6. So now, just to point out that the sine of pi by 6 is the sine of 30. And the sine of 30 is equal to a half. So we're solving when sine 2 theta is equal to a half. And so let's just do it on a clear space right here. Let's do it on a clear space. Because this one, I like to draw the circles when we do these type of questions. So we want to work out the sine 2x equal to the sine of pi by 6, which is a half. Sine of 2x is equal to a half. So if the sine of 2x is equal to a half, then 2x is equal to sine inverse of a half. That's 2x. 2x is equal to sine inverse of a half. And the sine inverse of a half, as we know it, sine inverse of a half is just pi by 6. Sine inverse of a half is pi by 6. Now that would only give us one solution, because if you're to draw a circle, what we notice is that sine, if we draw a circle, sine is positive in 2 quadrants. Sine is positive in the first quadrant and sine is positive in the second quadrant. So the first solution that we obtain is the solution for the first quadrant. So remember, CAST. So from AdMath Day, some of us might learn it as all schools teach crop. So sine is positive here and here. So since sine is positive here and here, then we get that 2x is equal to pi by 6. That's in the first quadrant. And in the second quadrant, we're getting 2x is equal to pi minus pi by 6. So 2x is equal to pi minus pi by 6. We may want to simplify this. So we may simplify this pi minus pi by 6 to get, we simplify it, we have 6 times pi is 6 pi. 6 pi minus pi is 5 pi by 6. So that is 2x. All right, so that's the solution. But the question wanted general solution. And so what we're going to then say is that the solution is that 2x is equal to, it's equal to pi by 6 plus 2n pi plus 2n pi. Now, why do we say 2n pi? 2n pi because we get the angle in the first quadrant, but if you spin around in a circle, if you spin around a circle one time, the same value that you get for sine 30, just using an example. So let's say you have the sine of 30, that's equal to a half. If you spin around a circle one time, you're going to get the sine of 390. And I guarantee you that the sine of 390 is equal to the sine of 30, that they're both equal to a half. So this would be the case when n is equal to 1. If you spin around the circle another time to get 2n pi, so that would be the sine of 360 plus 390. I believe that is 750. Not quite so certain, but I think that's 750. The sine of 750 is also going to be equal to a half. And that's when n is equal to 2. So you can check these in a calculator. These are all going to give you the same. Sine 750, sine 390, sine 30. They're all going to give you the same. Because what you're doing is spinning around in a circle. When you spin around in a circle, it's not going to change the value once it's one complete revolution. And so 2x is equal to pi by 6 plus 2n pi, or it's equal to, the other option was 5 pi by 6 plus 2n pi. So that gives you the value of 2x. Now we don't want the value of 2x, we want the value of x. And so what we're going to do is cancel 2 from both. We're going to divide through by 2. So dividing through by 2 is going to give us x is equal to pi by 6 divided by 2. It's going to give us pi by 12. And then this 2 will cancel a 2 because we're dividing by 2. And then for this, likewise, 5 pi, this becomes 5 pi by 12 plus 2n pi divided by 2. The 2's cancel. So the answer that we're looking for is going to be pi by 12 plus n pi and 5 pi by 12 plus n pi. That's it. So That's option B. N pi plus pi by 12, n pi plus 5 pi by 12. That's option B. Easy, soft, the capital T. Question 28. Question 28 is asking us to find, it says this, a circle has center -1, -1. And it says they want to find the equation of the tangent at the circle at the point 0, -3. So if you were to just draw a little circle, mine clearly is not drawn properly, but they tell us that the center of the circle is -1, -1. That's the center of the circle. Another point on the circle is -1, so to the right is 0. So another point on the circle is 0, -3. So let's say that's the point 0, -3. So we'll have some point right there that's 0, -3. And they want the equation of the tangent. So the equation of the tangent, this is what they want. The equation of the tangent. That's the tangent, right? But in order to find the equation of the tangent, we need to find the gradient of the normal and take the negative reciprocal. So that would be the normal because we have 2 points that would give us the gradient of the normal. So the gradient of the normal is going to be equal to y2 minus y1, which is -1 minus 3. So -1 minus -3 becomes -1 plus 3 over x2 minus x1, which is over -1. And so we get 3 minus 1 is 2, divided by -1 is -2. So if the gradient of the normal is a -2, then the gradient of the tangent is equal to 1/2. Because they're negative reciprocal of each other. And so if the gradient of the tangent is equal to 1/2, the only option right there is B. Because you can see they put -1/2, 1/2, -2, and 2. So that's B. Easy, soft. Question 29. Question 29 is asking for the cosine of the angle between the vectors -6j plus and I plus j. So remember, -6j is really the vector 0, -6. So it's really the vector 0, -6. And the vector I plus j is really, in vector notation, that is 1, 1. So the angle between the two vectors, let's call that theta. So theta, we know that angle between a vector has a relationship such that the cosine of theta is equal to the dot product of the two vectors. So it's equal to 0, -6. We're going to find the dot product between 0, -6 and 1, 1. So find the dot product. And then we divide it by the modulus of each vector. Now the modulus of 0, -6, that's just 6. Think about it. You don't need to find a squared plus b squared all square rooted, right? That's clearly have a length of 6. Because if you were to sketch it, let's say you were to look at it, on, let's say you were to look at it on a graph. So you have 0, -6. 0, -6 is somewhere right here. X is 0, y is -6. The length of this line has to just then be 6. Because if this is -6, the length of this line has to be 6. So we know that the length right here is 6. Now we have the point 1, 1. Now 1 square plus 1 square all square rooted, that's 1 plus 1 is 2, so we have the square root of 2. And then the cosine of theta is a dot product. The dot product is 0 plus -6. And so the cosine of the angle is -6 over 6 root 2. Now the 6's are going to cancel. And so this 6 cancel this 6 to get -1 over root 2. That's easy, that's alpha. So So that's an easy question, soft. Question 30. Question 30 is asking us to find the value of lambda such that P and Q are perpendicular. If P and Q are perpendicular, then P dot Q is equal to 0. If P dot Q equal to 0, then what we're solving is 2, 1 dot lambda 6 2, 1 dot lambda 6, that's equal to 0. So what we're solving then is that 2 lambda plus 6 is equal to 0, 2 lambda. Don't worry, my lambda is awful, I know. It's difficult to write. 2 lambda plus 6 equals 0, and so lambda is equal to -3. Lambda is -3. That's A. Easy question, soft. All right, so now, as we know, 15 questions come from module 1, 15 come from module 2, and now we reach the best module of unit 1, which is module 3. So it says, from the above, which of the following statements is true? It says that which of the following statement is true. Before we do this question, there's something I want to highlight, that just to recall, with straight lines, if you have a straight line that comes down like this, it has a negative slope, and so the gradient is negative, right? If we have a straight line, we're taught that the gradient is equal to 0. And if we have a line going up, then the gradient is positive gradient. All right, so now it asks, which of the following statement is true? F prime of 1 is less than 0. That means negative. Now let's go to F prime right here, 1. If you're to draw a tangent at 1, what you're getting is a line that's going down. And so right here at the point 1, yes, F prime of 1 is indeed negative. All right, now f of 1 is greater than k. Yes, f of 2 is f of k, f of 2 is equal to k, and f of 1 is clearly greater than k. F of 1 is right here, which is above k. F of 1 is above k, and so 2 is also true. Now it says f of 2 is equal to 0. F of 2 is equal to k, so this one is not true, because f of 2 is equal to k. That's not true. And then they say f prime of 2 is equal to k. No, right here, f prime of 2 is equal to 0. How do I know? Because the gradient at this point, when x is 2, is 0. And so this one is not true either. So only 1 and 2 are true. Only 1 and 2. Quite easy, soft. Question 32. Question 32 is asking, on the diagram, where's the function undefined? Now the function is undefined everywhere over here. So it's undefined for when x is less than 0. So when x is less than 0, the function is undefined. That's D. When x is less than 0, the function is undefined. Easy, soft. Question 33. Question 33 now says, for the function to be continuous, what is the value of p? If the function is continuous, then we know that g of 3 should be equal on both sides. So g of 3 on the left side should be equal to, so we need to find g of 3. G of 3 on the left-hand side right here is going to give us 3p plus 2. That's g of 3. if it's continuous at x equal to 3, so we have 3p plus 2, then we need g of 3 on the right-hand side. On the right-hand side, we put in x equal 3, and we're getting 3 times 3 is 9. 9 minus 1 is 8. 9 minus 1 is 8. So what we're solving is that 3p plus 2 must be equal to 8. If 3p plus 2 is equal to 8, we're solving that 3p must be equal to 8 minus 2 from both sides is 6. And then we divide by 3, and so we're getting that p looks to be equal to 2. So p must be equal to 2. Easy question, soft. P has to be 2. Nice. Question 34. Question 34 is asking us, a curve is defined parametrically by that equation, and they're asking for dy by dx. Now, to find dy by dx, we're going to have to use chain rule. So dy by dx is equal to dy by something times something by dx. Now that something is the parameter, in this case, which is t. So we can just put dt right here and put dt right here. So that's dy by dx. dy by dx is dy by dt times dt dx. Now dy by dt is going to be equal to the differential of y with respect to t, which is 2t plus 2, 2t plus 2. Then we're going to multiply it by dt by dx. Now dt by dx is 1 over dx dt. And so actually we're dividing by dx dt. dx dt is 2t minus 1. 2t minus 2, sorry. We differentiate minus 2t, we get minus 2. Now from this we can factor out 2 from the numerator to get t plus 1, and factor out 2 from the denominator to get 2 times t minus 1. So we're getting t plus 1 over t minus 1. We can just factor out 2 out of the numerator and the denominator, and they cancel. So that's B. Easy question. Just to factor out 2 from the numerator to get t plus 1. Factor out 2 from the denominator to get 2 times t minus 1. Not enough space right here. And that's B. That's option B. Question 35. Question 35 asking, which of the following function has a point of discontinuity? Which of the following function has a point of discontinuity? To find where a function has a point of discontinuity, you set the denominator being equal to 0. And so we set, in option A, we'd set x plus 1 all square being equal to 0. And from this, we get that when x is negative 1, the function is undefined. And so therefore option A has a point of discontinuity when x is equal to negative 1. Because if you put negative 1 into this, you're going to get 4 over 0, and 4 over 0 is undefined. That's a point of discontinuity. Now this function appears to have a point of discontinuity, but there is no value such that when you plug it in the denominator, you're going to get 0. And so Option B has no point of discontinuity. It's only option A. Question 36. Question 36 goes to ask us that a rod is heated at time t seconds and is given by L is equal to 5t squared plus 100. So what is the rate of increase of L? Rate of increase is dL by dt. That's rate of increase. What if they had asked for rate of decrease? Then it would be minus dL by dt. So dL by dt is equal to, when we differentiate, we carry down the power, so we get 2 times 5 is 10, and we get 10t. And then they want it when t is equal to 3. So when t is equal to 3, we get 10 times 3, and 10 times 3 is equal to 30. That's the rate of increase, 30. The rate of decrease would be minus 30. So that's question 36. Easy and soft. And so now we go to the final sets of paper for final sets of questions, which is question 37. Question 37, it's asking us to find the limit as x goes to 3 of x squared minus 9 over x minus 3. Now, if you directly plug in 3, you're going to get 0 over 0. So you cannot do that. So what you're going to have to do is to use factorization principle to do this question. So we have the limit as x goes to 3, limit as x goes to 3 of x squared minus 9, x squared minus 9 over x minus 3. Now that x squared minus 9 part, we can write that as being equal to the limit as x goes to 3, the limit as x goes to 3 of x squared minus 9 is really x minus 3 times x plus 3. We factorize it using the difference of two squares. We have x minus 3 over x plus 3. So we have x minus 3 over x plus 3, and it is being divided by x minus 3. It is being divided by x minus 3. And so x minus 3 divided by x minus 3, this x minus 3 cancels x minus 3. And so we have now the limit as x goes to 3 of x plus 3. So it's equal to the limit as x goes to 3 of x plus 3. And now we can plug in x being equal to 3. So plug in x being equal to 3 and we get 3 plus 3. And 3 plus 3 is 6. As we know, 3 plus 3 is 6. So that looks like option C. Easy, soft. Now question 38. So this particular question, I think for this year, many persons made some minor mistakes with this question. All right. Now this question, they want the area R. Now to find the area R, it is the area of the line minus the area of the curve. And I'm going to show you why. So we have a line, y equal x. I'm going to draw a line y equal x. This is a line y equal x. And I believe the question is asking from 0 to 1. So from 0 to 1. So now this is the line from 0 to 1. From 0 to 1. Now if you're going to find the area, if you're finding the area integrating from 0 to 1, what you're then finding is all of this. That's the area That's when you integrate the area of the line. That's what you're getting. You're getting all of this area, right? But then they also give us a curve. Let me put the curve in black now. They give us a curve y is equal to x squared. And y is equal to x squared looks something like this, right? That's y is equal to x squared. If you integrate now the line y is equal to x squared, integrate the line y equal x squared, what you're getting is, I'm going to put it in black, the part black, y equal x squared. This is what you're getting for y equal x squared. And so the remaining part is r. The remaining part inside here is r. So in order to get r, it's going to be the area under the line minus the area of the curve, and that's going to give you r. Let's write that down. R is equal to the area under the line, which is the integral from 0 to 1 of the area of the line. Integrating the line is y is equal to x dx. Then we're going to minus the area under the curve. And integrating the curve is integrating from 0 to 1 of x squared dx. So now this question is very simple and easy. So r is equal to, we integrate x, what we get is, add 1 to the power, we get x squared over 2. And we're going from 0 to 1, minus, add 1 to the power, x cubed divided by 3. And we're going from 0 to 1. And so plug in 1, and what we're getting is 1 over 2 is a half minus 1 over 3. A half minus 1 over 3, that's equal to 1 over 6. Very easy, soft. That's the area, 1 over 6. Here it is, option A. So again, it is the area of the line minus the area of the curve. So area under the line minus area under the curve gives you the common regional area between the two. So you can always remember that it's going to be area of the line minus the area of the curve to give the common region between the two. So that's option A. Question 39 now. Question 39 gives us that the gradient, they want the gradient at the point x equal pi by 6 and the curve y equals sine x. If y is equal to the sine of x, right, y is equal to the sine of x, then dy by dx is when you differentiate sine x to get dy by dx is equal to cosine x, and then the cosine of pi by 6 is what we want. So fine, we put in x as pi by 6, so we want the cosine of 30. The cosine of 30 is root 3 over 2. That looks like option D, which is very easy. Nice. So that's 39. Question 40. Question 40 says that integrate sec squared from 0 to pi by 4. Now, the integral of sec squared, as we know it, when we differentiate tan, we'll get sec squared. So because when we differentiate tan, we get sec squared. What that is telling us is that the integral of sec squared is tan x. Integral of sec squared is tan x. And we're integrating. Some people like to put a box, so let me put the box. Let me put the box. Integrating tan x, so put the box, and we'll go from 0 to pi by 4. This is not 6, this is 0. So put in pi by 4, we get the tan of pi by 4 is 1, minus the tan of 0 is 0. So the answer is 1. That's option A. All right. Now, question 41. Question 41 is saying, given that the integral from 2 to 5 of f of x is 9, find the value of the integral from 2 to 5 of 3f of x. So now, the integral, if we're to divide both sides by 4, what we're going to then see is that the integral, so that is telling us is that the integral of f of x, so the integral of f of x, I'm just going to write the integral of f is 9 over 4. And so if you multiply it by 3 now, you put a 3 right here, and you multiply this side also by 3. So what we're then saying is that the integral of 3f of x is 27 over 4. So that's the integral of 3f of x. I'm just putting f dx. So when I say f, it's a function of x. So that's 27 over 4. That is delta. Easy, soft. All right. Question 42. Question 42 says that based on the diagram, which of the following statement is not correct? It is asking us which is not correct. F of A is undefined, that is true. We don't know what f of A is, so it is undefined. It says the limit as x goes to A of f of x is f of A. Now if f of A is undefined, then we can't know the limit. So this one is not true, that's B. And that's too easy, soft. All right, question 43. I really like question 43, and the reason being is for this very reason. It asks us to find the volume around the y-axis. Now, volume around the y-axis is different from volume around the x-axis. Volume around the y-axis is given by volume is equal to pi times the integral of x squared dy. That's the volume around y-axis. Volume around y-axis is pi times the integral of x squared dy. And so the volume is pi times the integral, and we're integrating around the y-axis, so it's from 0 to 3, from 0 to 3 of y of x squared. Now x squared is equal to y, and so we'll put y dy, and that's the volume around the y-axis. That's going to be D. So that's D. A lot of persons sometimes put A, and the reason for that is volume around x-axis. So just to write it down, volume around x-axis. Volume around x-axis is different from volume around y-axis. Volume around x-axis is given by volume is equal to pi times the integral of y squared dx. That's volume around x-axis. Volume around x-axis is this. And so, of course, if you were finding volume around x-axis, it would be x squared, which become x to the 4. That's volume around x-axis. Volume around y-axis is pi times the integral of x squared dy. Critical to know this. Very critical. This is volume for y-axis. Volume for y-axis. Very critical. Volume around y-axis. Put our box around it. Volume around y-axis. So that is dog. All right. Question 44. Question 44 is saying if f double prime is equal to 6x and f prime of 0 is 0, find f of x. F double prime is 6x, and so then f prime of x, f prime would be equal to We integrate 6x to get add 1 to the power divided by the power, which is 6x squared over 2 plus some constant c. But this constant c is equal to 0 since f of 0 is 0. And so f prime is 3x squared. If f prime is 3x squared, then f is going to be equal to add 1 to the power, we get x cubed divided by the power, because 3x cubed divided by 3 is just x cubed plus some constant c. So that's f, which is d. Finally, the last question, it's asking us to find the differential of x cubed sine x. The differential of x cubed sine x is, think of this as u and this as v. So as we know, it is v du plus u dv. v du plus u dv. So v du plus u dv is going to be equal to v, which is sine x times du. du is 3x squared times v, 3x squared sine x, plus u is x cubed dv. And dv is, differentiate sine x, we get cos. We get cosine x. And so what we then do is just factor out x squared, since x squared is in common. We factor out x squared and we get 3 sine x, 3 sine x plus x cos x, x cos x. So 3 sine x plus x cos x. So that's 3 sine x, x cos x. That's D. And that's question 45. That's it. Easy, soft. And this is the end of 2016. Very easy paper. Very easy paper. So give me a minute. I'm going to open 2017. I will start 2017.